Hello everyone and welcome to today's Safety and Health webcast, Machine Safeguarding and its Impact on Alternative Methods to Lockout, sponsored by the Master Lock Company. This is Alan Ferguson, Associate Editor at Safety and Health magazine, and I will moderate today's session. Thank you all for joining us. We'll start the presentation in a few minutes, but first I want to go over some preliminary items. The views of today's speaker and organizations are their own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Any mention of a commercial enterprise, product, or publication does not mean the council or magazine endorses those items. At the end of today's webcast, we will conduct a question and answer session. To ask a question, simply type it in the text box in the lower left-hand corner of your screen and click the button for Submit Question. Feel free to ask your question at any time during the presentation. You don't have to wait for the question and answer session to begin. We'll try to answer as many questions as possible, but because of the large number of participants today, we might not get to every question. Any unanswered questions will be forwarded to today's speaker. For basic troubleshooting information, click the Help button located on your screen. At the end of the webcast, you'll be asked to complete a brief evaluation survey. I will let you know more about that after the presentation. This webcast is archived, so you can access it after today's live event. To view this webcast and all of our past webcasts, go to safetyandhealthmagazine.com/events. With that, let's go ahead and get started. Our speaker today is Todd Grover, Global Senior Manager for Applied Safety Solutions at the Master Lock Company. Todd has more than 30 years of experience as a practicing safety professional and EHS manager. He has worked with many industries to develop lockout policies and procedures, prepare company-specific compliance training, and perform accident investigations. Todd has an advanced safety certification from the National Safety Council and is an authorized instructor for OSHA's 10 and 30-hour courses for general industry and construction. Todd, whenever you're ready, go ahead and take it away.
Well, thank you, Alan. It's really a pleasure being here today and being able to talk about a nuance of safety related to lockout and machine guarding, and see if we can't put those two together. I'll be talking today from the context of both OSHA compliance as well as the work I've performed with the ANSI Z244 Committee on Lockout Tagout and Alternative Methods. Recently, a highly revised standard was released in 2016, December of 2016, and much of the information on alternative methods we'll talk about today are derived from the standard and use some of the methodology discussed. Now, because we do have a large number of people today, I'm going to try to balance my comments between good basic foundational information and then the nuances that are on top of people's minds in terms of how does my machine guarding support my lockout program and vice versa. So with that, let's go forward and get off to a good start. The idea that we want to register is that the day-in, day-out protection that your machinery provides for your workers is directly related to the machine guarding surrounding it. And the use of safeguarding is not only for operations, but it is to enhance the ability to maintain machinery and to have access to it for adjustments and routine and repetitive type activities where hopefully the machine guarding enhances the ease of getting to those tasks, the areas of the machine where the work is done, or even allows the tasks to be done with the machine guarding in place. That would be ideal. Machine guarding typically focuses on the point of operation where the work is done to transform materials, as well as any part of the machine that moves or is power driven that could cause injury to people that may come in contact with it. So really, in doing a machine guarding survey, it's best to observe the machine running and in operation and ask yourself, are there any areas of this machine, any movements or function it's performing that would hurt somebody if they got engaged in that area? And is there anything preventing that from occurring, whether that be a barrier-type guard or presence-sensing device that's going to stop the machinery immediately if that contact is made or that barrier is broken? Now, the idea behind these safeguarding principles not only applies to machine safety, but also the way we service equipment. Good guarding enhances access and drives efficient maintenance. Bad guarding is a frustration to people. It inhibits productivity. And my finding over a lot of years is many times it's removed or defeated to make access easier to get the work done, and therefore is no protection at all to the worker who may be counting on it as the line of defense between them and the aspects of the machine that could hurt them. So a couple of quick things, just as a review. We want to prevent contact from occurring. The person should not be able to reach through, around the guard and reach that danger point behind it. The guard should be rigidly connected to the machine so that it is not going to be inadvertently knocked off or put ajar and machinery will be allowed to run with a gap or exposure for the worker. We want to keep things from falling into the machine. That especially goes for maintenance activities where tools or materials left behind could be projected out upon sudden startup. We don't want to create any new hazards with the guarding. This is really important when we consider alternative procedures because it's risk assessment based. And so if we're simply assessing the machine as it sits and now our new guarding creates other problems, that's not a full risk assessment. We can't appreciate what could happen to the person trying to interface with this guarding. It should not create interference. Now that's an ideal world. But the idea would be the guarding is simply there to keep people out of trouble and does not get in the way of getting the work done, which may not only be contact, but it may be line of sight visibility. It may be other aspects of monitoring the work and making sure the machine is doing the job it should. And whenever possible, guarding should be designed so that the simple tasks that happen routinely can be done with the guarding in place, so we don't have to take things apart, creating an exposure. And as soon as we do, we have to remember that lockout is required anytime guarding is removed and people come in contact with either the point of operation or a danger zone associated with machinery movement. So crucial because this guarding is a signal to people that if I'm moving this guard or opening it up, I better be locked out before I do it because there is no more protection between me and what could hurt me. Okay, so as we look at these guards, the hazards that we're trying to protect against are exactly those that could cause the source of injury if the machinery would suddenly start up because energy has not been adequately controlled. And lockout will control that energy adequately, but what we're talking today about is alternative methods where power needs to be present in order to do certain tasks. Certainly we'll get into that in more detail, but the idea is these kind of mechanisms of injuries, being crushed or pulled into the equipment, struck or pinned against a fixed surface by a moving part, hit by something being pitched out of the machine, whether that's routine operation and the barrier is not so much to keep you from getting in, but keep machine parts or other materials from being projected out. That can be a real hazard in sudden startup where the guards have been removed. Okay, there's a list of things that need to be considered for guarding, and that should be part of any preliminary assessment of the machine. Now, there are some good machine guarding assessments forums out there. They do a nice job of breaking down what should be considered in doing machine assessment. And for those listening, I would encourage you to find a format that you like. And if you have a format that you like right now, take a look at what you may find online or through other resources such as the ANSI B11 guarding best practices. just make sure that you are using what would be the very best practice for your organization. There's always time and opportunity to improve when you take a closer look. These hazards that the guards shield your people from are the very same things that will cause the accidents when the guarding has been removed and lockout may or may not have been sufficiently applied. And in our experience, over the years, we've seen lots of accidents occur, possibly because some lockout has been applied, but it has not been fully applied. Maybe residual energy that's not been fully considered, or maybe somebody has justified why energy needs to be present to do a certain job. That allows a mistake in human judgment to create a startup scenario, and that's where these accidents can happen. We're trying to blend the best of machine guarding and a good practical approach to controlling these exposures if indeed an alternative method is chosen to be used. Now, OSHA focuses very strongly on recognizing that lockout, as written in the OSHA standard, is the minimum performance requirement for controlling hazardous energy. It is meant to complement and add to a machine guarding safety program in terms of being the safe work practice when the guarding is not in place to do its job or has been turned off or otherwise defeated to allow access. We realize that lockout is time-consuming. Everybody tells us this. It's nonetheless an essential task to be able to perform, but when good and smart guarding reduce the likelihood of lockout needing to be applied as frequently, that is an efficiency aspect. And if you're designing guarding or if you're intending to invest in guarding improvements, that efficiency calculation is a really important one to make to see if there isn't payback from doing things better, from improving practice and methodology. That's kind of where the ANSI standard comes from. The best interventions are the one that don't get in the way and add to productivity. OSHA recognizes that there are a number of tasks that are routine, repetitive, and integral to production that are not covered by the lockout standard. However, they do require equivalent methods of protection to be put in place that offer the equivalent safety as lockout. You can't use an alternative method that is only half-baked, half protective, counting on coincidences not happening. That alternative method, if allowed to be used, is got to be consistent and reliable. And what I've found in a lot of businesses is there's an awful lot of alternative methods being used that are not documented, that are really up to the judgment of the operator who's deciding whether or not it's routine and repetitive. And there is lack of consistency because these procedures, these alternatives to lockout are not well documented and trained to people. So a question I would have for the audience to ask yourselves, if you went out there and looked at what your people might be doing under this exception, under the OSHA lockout law, is there consistency? Is it well documented? Are each of your operators essentially performing the same protective precautions because the methodology is well understood, they've been trained how to do certain alternative methods? There's a list of what you would consider to be acceptable alternative methods, and that's what your people limit themselves to. If you're like the majority of companies I see out there, there is nothing like that out on the floor. It's essentially a little uncontrolled when it comes to what are people actually doing, when is it legitimate, when is it not. And when we enforce lockout against our employees for failure to lock out, one of the most common arguments back is, oh, this meets that exception, routine repetitive. Question is, does it really? Is the level of protection equivalent to lockout? So lockout needs to be applied anytime multiple people are servicing or repairing machinery, multiple people being one or more, and it's possible that unexpected startup or a release of energy that could hurt them could take place. Anytime a worker bypasses or removes any safeguarding devices designed as a barrier or presence sensing device and exposes themselves to the point of operation, the machine should be locked out prior to that guard being defeated. So if any aspect of their job requires them to go into danger zones, putting their body in contact with point of operation or an operational area of the machine, danger zone associated with movement, lockout needs to be in place before they go into that level of exposure. Now, the ANSI committee looked long and hard at this aspect, and we thought, is there ways of improving practice based on what industry is showing us, latest methodology and technology, and we tried to reflect that in the newly revised standard. However, we want to come back to the point, the ANSI committee believes strongly that isolation with lockout shall be the primary method of controlling hazardous energy. And so any machine where we would consider an alternative procedure should have as a foundation a lockout procedure addressing all the energy sources and how to control them. As a personal practice, I would never consider performing assessments for alternative procedures unless I knew there was a lockout procedure that would be used for the major repairs, the disassemblies, when, for instance, we don't fully understand the risks the workers are taking on. So in the absence of a risk assessment or when the tasks we're performing have never been done before, not well understood, lockout should be the default precaution, even if we think that's inconvenient. It's worth the time and energy to apply lockout well, test the controls for zero energy, have something we can rely on, because we need to fully understand what we're doing if we're going to use something other than lockout to fully protect our workers. Now, tagout, if you're using tagout, any of you, that should be well documented in a tagout procedure and recognize that you may need to add other protections in addition to tagout because it's not viewed as equivalent to lockout. Tagout is right up there. It's in the title of the OSHA standard, but tagout by itself is not deemed to be as protective as lockout. Less preferred because we don't necessarily have exclusive control. We may hang a tag that protects a number of people. Okay, it's more susceptible over the years. It's been proven to people defeating it, cutting off the tags, or the environment doing damage, and removing that tagout warning. If there's not something additionally done to protect people, tagout falls a little short. It could be considered as an alternative method. For instance, tagout in place of lockout might be justifiable, especially with that extra method in place. So we'll explore how that can work in terms of assessing alternative procedures. Now it's clear, according to OSHA, that small and routine tasks, routine, repetitive, and integral to normal production are what their exceptions apply to. And this is, this needs to be documented. We need to know what that short list is. We need to know what is expected to be done if we're not going to lock out under these. And so one of the aspects of alternative procedures and the format that ANSI has provided is to help document your existing procedures that people are doing and you know about it. You know, we have a list of 3 things we allow an operator to do on a machine under this exception. The ANSI methodology will help you simply to record what you're already doing and verify that indeed it's a safe practice. So that's one of the uses of alternative procedures. Now, ANSI Z244 in our recent release is broader in its scope. It is not saying that strictly production-related tasks are the limitation of what this can be applied to. So some of my comments today may kind of go beyond that strict OSHA compliance requirement, but the idea is whenever maintenance, servicing, repair, inspection, things that are outside of production, which is I'm keeping the machine going, doing what it's doing. That's when I'm going to use this alternative method. There may be reasons power has to stay on to do certain tasks, or it may be impossible to lock out for maintenance and repair and tasks. That's where we've looked at the success ratio of a risk assessment-based alternative method and prescribed alternative measures, being able to generate a confidence that this machine will not suddenly start up or release energy. We do this through a threefold approach. The first is a practicability study or justification. I'm going to show you that. It's a straightforward process. It decides, really, do we have what's necessary to even progress into analysis? The next step is, once we decide this is a credible task to assess, there's a risk assessment process that says, what are the exposures and what are we doing about it to control people? We're measuring risk before and after controls and returning a well-controlled negligible risk to perform the task using the specified methods. And then we use other evaluations where necessary. I'm going to talk to you a little bit more about those, but in addition to the risk assessment, there are some benchmarks that can be applied to your alternative method and decide, is this truly sufficient? So that's really what we're going to be talking about a lot of the remaining presentation today. Alternative methods, the questions, are they overused or underused? And I think the consensus out there is alternative measures and the decisions workers make is that they are overused. They're too liberal, and we need to have better definition of what's going on. Now, interlocked guards or emergency stops are not considered by OSHA to be effective protection by themselves. Okay, we're going to talk about control, reliability, and so on, but basically at the time the OSHA law was written, which was based on the ANSI standard that was written in 1982 with research from the 1970s, we're looking at a very old standard that reflected truth at the time, which is e-stops and interlocks are nothing you want to stake your life on. They are simple measures that wear out, that can break, that can fail, and can create exposure issues to people. However, we looked in our committee work at the idea that advances in guarding technology has produced a whole new breed of control reliable systems, and in fact our machinery can be so complex that a reliance on these control reliable systems may be a much better engineered solution to controlling risk to the worker rather than depending on an administrative control, which lockout clearly is. An engineered control is designed to work consistently every single time and fail in a safe condition if a fault occurs. An administrative control is, I'm going to take a worker, I'm going to prepare them through training, I'm going to give them a method to follow, I'm going to set them up with the right equipment, and I'm going to hope for consistent results in application. In a well-run lockout program, we get those kind of performances, but people inconsistently apply lockout at times, hence the number of accidents and its level of importance given on the OSHA's top 10 list. It routinely ranks 3, 4, or 5 on that list in terms of most cited events in terms of accidents reported or complaints filed. Okay, so there's more on this in the Z244 standard, but I just want to hit on a couple of high points. First of all, there's a lot of information on reducing risk by the design of the machinery. Can we make this easily lockable? Can we get ahead of the tasks that have to be performed and design the safeguarding and the ease of lockout to make it very straightforward to workers to solidly protect themselves either during operation or during maintenance and repair? And so design trumps everything else. It engineers and eliminates out the hazards. So we like going that route whenever possible in terms of new machinery. being specified in or modifications to additional machinery. Risk reduction by engineering controls also is a factor that needs to be considered. What is the level of your capability with the safeguards on your machinery right now? Are you thinking about updating? If so, you're considering technical improvements to the safeguarding systems. Also consider what tasks may be benefited by engineered solutions in terms of more control, reliable, and robust safeguards. Okay? One of the things that we look at, which actually is above lockout tagout in the hierarchy of controls, is warning devices or warning devices, something that would flag workers that a danger condition exists to clear area or take a safe working distance, and prohibits the activation of machinery until people are in a safe position for activation to occur. So, and hence warning awareness can be elevated in the engineering status if it can be shown that reliably these warnings are going to be given in order to get people out of the way. Then we have administrative controls. And yes, I'm showing lockout as one of those administrative controls. A lockout full isolation procedure is a must for any multiple energy sourced piece of equipment. It should be available and people are able to follow it. But also, you have standard operating procedures, and that may minimize the likelihood of problems. You may have maintenance work procedures that are spelled out as to how certain tasks are done, including testing or positioning of machinery. You may have alternative procedures that say if we can't lock out under certain circumstances, we have determined the methods to be followed are A, B, C, and D. And that has to happen every single time. You can't do it your own way. You can't take shortcuts. Finally, risk reduction by personal protective equipment is on that low echelon reliability, very dependent on whether the people use it and whether it's in good shape, but it can be a final buffer that could be added in as a layer of protection to these alternative procedures. So why wouldn't you want to lock out? People scratch their head, and a lot of us know, though, because we hear the feedback, it's tough to lock out. I cannot lock out and get this job done. What do you expect me to do? Or it is so hard to lock out because I have to get a scissors lift to reach the valve in the ceiling. Okay. When energy must be present because it's required to do the work, we have a solid argument as to why full lockout may not be feasible. However, what can we lock out, leaving only the energy source we're well aware of and may be able to control in other ways? There may be hazards such as two given as heat energy, radiation. They may be present, and short of a cool down period, which could take minutes, hours, long time, we're consistently seeing people using PPE against that residual energy source without any alternative procedure specifying what has to be done. And that would be an energy source. That has to be identified in an alternative procedure. Sometimes energy is required to maintain equipment in a safe state. Whether or not that may be energized safeguarding systems that detect faults and prevent activity from occurring, that may be one aspect. There may be safeguarding systems that hold process chemical systems in a controlled state. If that energy was lost, protection would be downgraded, and then hence the task could be greater. Warnings, alarms, sensors, things like that may need to be energized, hence there's energy still in the machine. And often it's necessary to preserve important functions. And people will tell you any number of reasons why they have to keep their data settings, maintain a certain temperature, or be able to move the machine in order to test function, make alignment corrections, that kind of thing. For troubleshooting, electricity's got to be in the system to know if it is going the right place at the right potential with the right amount of resistance. So that may be a reason electricity has to stay present. We may be testing pressurized systems. There's any number of reasons why during troubleshooting energy must be present. Right now, if they're just troubleshooting, they may be in violation of lockout if the energy is present. What alternative procedure could reflect safe working methods for these type of troubleshooting activities? And let's be honest, timing is an issue where people are routinely doing simple tasks because in their minds and in the minds of management often it takes too long to lock out. Okay? If that's the case and it becomes a test of feasibility, we may ask, is there an alternative method that is confidence-inspiring enough to say this machine absolutely will not start up while they're doing a certain thing, and here's why. Here's the layer of protection we put in place. Okay, so there's many reasons why people are challenged by lockout, and a lot of them have to do with getting the work done. They can't do it as they feel it needs to be done with lockout in place. We'll talk more about alternative procedures and how that can answer some of those questions. So tagout certainly is an alternative in the short term that may flag an isolation device and keep it from being activated. But in addition, look at adding something to that tagout. Here's the common examples. Blockout means I have physically restrained something that could move under power from moving by putting something in place that will restrain it and not allow that to take place. It could be propping or chaining up a raised surface. It could be, as we're showing here in the picture, I'm using a two-step approach here. I am using a blocking mechanism to support weight, and when I retrieve that blocking method, I'm pulling an interlock plug out of the machine, setting an interlock that keeps that machine from operating. So I've got two layers of protection there. First one being the interlock as it's unplugged. Second one being the presence of this blocking device that would prevent movement from occurring. Of course, the operative condition is, did the blocking device get put in the right place, and is it fully supporting what could move on me so an accident could not occur? Now, interlocks can be used in a layered protective structure. We'll talk about control reliability in a moment, but the idea here is I've got two layers of protection. Not only did I open an interlock on a gate that indicated to the machine, do not run while this gate is open, but I've also put a presence sensing device underneath, like a pressure sensing floor mat. There's a lot of use of laser scanner technology that can detect any disruption to the presence of people in the guarded area. Sometimes when we look at safeguarding, we look at layers of safeguarding protection that detects people a number of ways. Okay, so we'll talk a little bit more about that. When we talk about control reliability, what we found is European machinery that has had a higher degree of control reliability has been available since about the 1990s. Not a lot of it made it into the United States because it was costly. People didn't see the benefits of control reliability. So you might have it in your workplace, but certainly if the equipment was not built, in the 90s or later, unless you've retrofitted a highly control reliable system, you should count on the idea that you've got category B, 1 or 2 in your machinery. Yeah, the interlocks are there, but they will not necessarily fail safe. They will not necessarily catch faults that occur. So I show you a basic e-stop switch. Those are strictly on-off. A lot of times those are set as the only precaution taken to keeping the machine from starting up. Any maintenance department can tell you those switches can fail and allow the machinery to run. They can be worn out by overuse. There really is nothing more than basic on-off type functionality to a Category B, and they're widespread. Category 1 increases durability. It can be cycled more frequently. Typically, they're well-tried and components with a good safety record. However, the occurrence of a fault can lead to the loss of a safety function. It's simply that the probability of occurrence is lower than for the very basic protection we just talked about. Category 2 builds on Category 1. It's the first time that safety function is checked at intervals by the machine. A relay system is the most common way of checking Category 2 versus a process logic control, or PLC. The occurrence of a fault can lead to the loss of a safety function between checks. The loss of the safety function should be detected with the check, but these systems tend to be easy to bypass, tend to be easily defeated, and so often you will see machinery where the interlock physically is in place, but it's not functioning and the machine is operating happily without it. That may be a characteristic of a Category 2 type interlock system. Category 3 takes all the Category 2 aspects, but it's a more carefully monitored system. A performance scan is completed each time the safeguard is activated. It could stop the machine before access to the danger area occurs, as long as the guard is designed properly. Any fault in any of these aspects will not lead to a loss of the safety function. When the single fault occurs, the safety function is always performed. A PLC system is the most common way of doing this. An accumulation of undetected faults can lead to the loss of safety functions. And so a Category 3 guard is a big step towards control reliability, but you have to look at the hazard related. If you're asking people to bodily enter an area that could create enormous harm to them, a Category 3 system may simply not reflect well on a risk assessment. That if a series of faults could occur, this system does have a remote possibility of failing, allowing the machine to run. Understanding more about the capacities of this Category 3 system are very important. Category 4 is a continuously checking, pulsing system. It is used to tracking the presence of multiple and overlapping faults. It will consistently fail into a safe condition before the next demand on the safety function occurs. So this will preemptively shut itself off. Accumulation of faults will not lead to a loss of safety function. And when the faults occur, the function is always performed. So this is a highly, highly sophisticated and reliable system. You will find it in modern machinery. You will find it difficult to install retrofit into existing machinery. Not to say it's impossible, but there's got to be an investment made. And certainly you'd like to see the payoff is increased efficiency and productivity if you're going to go to that extreme of modifying existing machinery by that design stage. Now, let's talk about the methods of alternative control. We are looking at two areas, practicability and justification analysis, which says, what will lockout do if we apply it? What can we do to minimize the exposures to the worker? And just on a surface level, what potential alternative method should we consider as we start our analysis? If we don't answer the questions well, it's hard to get beyond a practicability analysis. And here's another use of this alternative measure evaluation. If your worker comes to you and says, hey, I cannot lock out this machine because of these certain factors in that work I have to do, you can, in a very straightforward and user-friendly manner, work with that worker to go through some basic questions. And if it comes out that, hey, there is not a good alternative method, there's nothing reliable, there's not good justification as why you can't lock out, it comes down to you don't want to lock out, it's the extra step, it's a hassle. But as you can see, we've gone through these questions together, and you're not safe doing it the way you've been doing it. One of the things with alternative procedures is designed to say no to the activities that are simply not safe to perform with less than lockout. So by no means is our alternative procedures designed to always bless the activity and move forward. Sometimes it's to create a stop. When we do practicability analysis, and we say, yes, there's merit to this. Let's see what we can do. Let's go further with a risk assessment. We're going to talk over a couple of aspects of what that risk assessment consists of. It's well set up in the ANSI standard. We could spend all session on risk assessment alone and still not cover all the bases. So this is an example of the practicability analysis. And just to run you through the questions, are energy sources required to be present to perform this task? And if the worker says, well, no, not really, it's pretty hard to go forward and not justify locking out the machine. But does the application of full isolation lockout currently limit the ability to perform the task? If so, why? Let's talk about that. Are there foreseeable modifications to the equipment that would make it easier to lock out? So if I don't need a scissors lift to get to that valve because I moved it down to the floor, if I can install local disconnects, part of the design emphasis that's been given to new machinery, let's make this as easy as possible to lock out, then we want to pursue the ability to improve lockout access rather than justify bad practice or insufficient risk control and alternative procedures. Okay. Then we're going to go forward and ask, are there ways to reduce the number of energy sources present? If I got 3 energy sources and I'm just doing electrical circuit testing, let's lock out the air and the hydraulic. Okay. Let's let a cool down period happen or stop the flywheel from spinning. Let's control everything we can so we're only dealing with electricity, which now becomes a qualified person's responsibility who should be trained on electrical safe work practices. But it could be the hydraulic system that has to be tested. It's not by any means saying more than let's limit the amount of energy present to just what we need to work with. And then we have got an opportunity to say, just off the bat, what do you think we should look at in terms of alternative methods? And here the operator has a chance to give feedback, or the maintenance person to the safety person. You've got a starting ground to start your assessment. So this is quick and dirty practicability analysis. I find they take somewhere between 30 seconds, if you answer no to the first one, and about 15 minutes to really sit down and justify, should we put the effort into a risk assessment? Now, the task hazard assessment, when it goes forward, is a task-by-task analysis deciding what required controls should be in place. All tasks and activities should be considered. A lot of the things, including OSHA's list of things that require lockout, may very well be those problematic tasks people can't do with lockout for a particular machine. Okay, you should consider all hazard-related sources of energy, which means that foundational lockout procedure hopefully discusses not only electrical and air pressure, but stored air pressure and spin down time and temperature release and proper positioning of the machine. So it's in a resting position and gravity is alleviated. All these things go into the hazard assessment. We're just not laser focused on one energy source and blind to what truly could hurt us. Okay? Consider the nature, duration, and frequency of exposures. What's really happening here? Is this truly a minor exposure that really would not result in harm? That's easy to note in an alternative procedure that may be for a routine and repetitive and integral task. Or if it is a highly complex one, it may demand engineering solutions as its best and only outcome. Be honest and conservative. If somebody could still get hurt despite what you want to do for alternative measures, it's clear the task requires lockout to be applied. So no matter how much you want to go to an alternative procedure, if the task cannot be done, you got to lock out. If you realize as part of your assessment, hey, there's a couple of things we could do, but we'd have to invest in and we'd have to make the changes, you need to lock out until those changes are made and a reassessment proves this is now a highly reliable alternative measure that will not allow startup to occur. Feasibility of lockout. when we start considering these tasks, these are the considerations that often come up. The idea is we don't want to bless complex tasks with lots and lots of exposure. We want to do the day-to-day stuff that really give people fits when full lockout gets in the way of getting the job done. So I'm not going to march through this list of things, but these are just some of the hallmarks we look for when somebody comes and says, hey, I got a challenge with a task I got to do. Can you help me with assessing this alternative procedure I have in mind? These are some of the characteristics of tasks that respond well to that kind of alternative method evaluation. Alternative methods are often developed into procedural instructions that go out with the machinery. For any alternative procedure, we should look at who's actually going to use this thing. It's not a blanket procedure for anybody to use. There should be a training roster associated with each alternative procedure to say only those who have been through training and understand exactly what we mean, because a lot of this, again, is administrative control. We are expecting people to do as the procedure instructs using tools and methods that are subject to human interpretation and behavior. But the idea is, if I've trained a person how to use this, that is certainly a step in the right direction of assuring they know what we're expecting and can perform as specified. Okay. This is just an example of a task hazard assessment. We're looking at something simplified in terms of risk assessment. The idea would be before any controls are placed, what could go wrong? What would be hurt? What's the expected outcome? And we may find that as we do an assessment, nothing really could happen to a person. If this machine suddenly started up, it wouldn't really cause any harm. So we may find simply that as the task stands, it's acceptable. Go ahead. We've got now a documented method to do it. But if we get into conditional or unacceptable conditions, we need to do that risk assessment, move it up. The assessment boxes on the right-hand side show post-control evaluations, again saying, what could happen, what is the likelihood it's going to happen. And we're drawing the line here in this simple assessment model at a first aid case. If what's going to happen is likely to provide more than we can treat with our in-house resources, then we've not achieved an acceptable level of risk, and we should hold back. Here's an example of a task hazard assessment underway. It's summarizing the tasks to be done, which is changing the die block. We're listing risks, recognized hazards. We're recognizing here in this preliminary discussion what we think would go wrong, and that it's an unacceptable condition as it sits without any controls in place. Here is the assessment now done post-control. We're specifying what has to be done. Again, everything is changing the die block, but we are finding we've achieved acceptable conditions on the top two with the controls we've put in place, but we find we have not gotten to an acceptable position at this point on the last hazard assessment aspect that we're doing, saying there is not adequate guarding in place at this time. This means for a failed hazard assessment, we're not ready to proceed, but we are ready to pursue guarding improvements based on this risk assessment that could drop the risk down to an acceptable level. Once installed and tested, we may find a very suitable solution to this process. So again, I'm just looking at time and knowing when we want to do some questions. This happens to be an example of a risk assessment showing certain points, given certain instructions. This is kind of a blow up of that smaller procedure that I had shown previously, more of a discussion-oriented one. I want to give you some time for questions. I'm sure there will be some. So let me move forward and just say this is what then might get posted on the machinery. That this is a task summary for a mechanical power press. It says these are the normal tasks that have to be done. This is what we've determined the personnel that perform the tasks are, so we know who we're talking to. We identify the hazards, and we show that before any controls, we found unacceptable or conditional danger conditions in these. We then show the control measures at a minimum, and some of those line items specify a specific alternative procedure. That would refer to the format that I've shown you for the person to be trained on and need to be followed. If it's done, the risk assessment says this is an acceptable condition, let's go forward. However, it does clearly specify the 3 tasks on the bottom that there is no alternative procedure necessary or any that we can approve as is. Therefore, lockout is a requirement. And this is a great guideline for training purposes, for people walking up to the machine. What task am I about to perform? What do I have to do? Is it an acceptable level of safety, or is lockout going to be the requirement for protecting myself while I repair or service this machine? Now, we moved through things really well. I wanted to leave about 10 minutes for questions. I'm sure there will be a few. Alan, if you could share with me what's come up from the audience, I'd appreciate it.
Great job, Todd. Thank you for your excellent insights and expertise. Before we start the Q&A, I want to remind everyone of the evaluation survey we're asking you to complete. The survey should be appearing on your screen. Your input is important because it will help us improve future webcasts. If you do not see the evaluation survey on your screen, please turn off your pop-up blocker. You may also access the survey by clicking the survey button near the lower right part of your screen. Okay, now let's get to some questions. Can you use e-stops when changing inserts that are considered integral to production and routine?
Good question. And not to beat around the bush, but what are the level of the e-stops? How reliable are they? Has an assessment been done to determine if truly you can count on them or not? What's the exposure to the worker? Is it going to be a nuisance level type injury, or is it something that's going to wrap him up in the spindle and suck him right into the machine if that thing starts up? So I would say that there's plenty of people who do use e-stops. However, I would point out that that's one level of protection. We'd like to probably layer a couple in place. It might be that an e-stop on top of an interlocked reliable guard system might be enough. It might be that there's a way of restraining by a brake, the activity or ability of startup to occur. I would certainly say it's a common enough task, but an e-stop alone that somebody else could pull out and press the button, or you could, forget to set the e-stop and hit the button inadvertently and start the machine up, probably not enough simply to hit an e-stop.
Our next question, we have a hand press that needs guarding. I don't see any way to apply a guard in that we have to press large items. Any place I can find info? I've already contacted the manufacturer.
Yeah, and many times there is nothing from the manufacturer. It's interesting, Alan, that he said hand press, which may mean hand actuated with leverage, but it also may be a powered press that is just loaded and unloaded by hand. There's a lot of really good guarding resources out there. I'm sorry to drop names, but it's an awfully good one. I find that Rockford Systems is just very instructive on the possibilities. So there's other good resources out there. I would throw that one out as a fast step towards evaluating and getting more information.
For our next question, what about moving parts that need to be cleaned or adjusted while the parts are moving? Barriers or presence sensing devices would not work in that case. Are there any options?
Yes. There always are when you understand the big picture of what's going on. The question would be movement. Why does it have to move in order to clean? Is the movement rate for production the same as we would require for this cleaning function. For instance, one solution that I've seen companies use effectively is the process has got to keep moving, but I can slow it down drastically so that the likelihood of an injury goes way down, the likelihood of being able to retract my hand if anything would happen may improve things. I don't know if speed is the solution there, but I'm throwing out there that the danger of speed is the ability to be pulled in before you can react and velocity doing harm. If you can reduce the speed to a point where you can anticipate, what may happen and there's no velocity that would add to the injury, I'm not saying that's a solution. You'd have to look at the situation exactly, but I will throw out there, just as an example of risk assessment thinking, I would start with considering the speed of the way that task is being performed. Is it safe as it is? Can it be slowed down?
Our next question, what do you consider short in duration? Is there a guideline in terms of minutes?
There's no guideline in terms of minutes. Duration is often measured in how immediately able is the worker to do the job. For instance, if it's just their fingers that do the work, and it's a quick manipulation and we're back and running again. If it is everything they need is right there, including the tools and the materials, so they can, immediately get to it. But if I got to stop what I'm doing and go get what I need, that I would say is not short duration. That may be one hallmark. Short duration is also measured by, again, we got to consider the consequences. It may be short duration, but it may cause horrible injury by falsely counting on stopping the machine as the only protection that you're taking. So here again, a layer of safeguards, that if I have a highly controlled, reliable system, or if I have maybe a Category 2 interlock system, and instead of hand contact, I use a reach-in tool as a second method, a second layer of protection. Again, you always got to see the task and assess it properly, but that may be an example of a couple of layers of protection that may be sufficient for a short duration task. But there is no hard and fast number on it. It typically has to do with the spontaneity of the person being able to do the work.
Taking a piece of equipment out of service, do you apply Lockout Tagout?
Yes, absolutely. If it's out of service, then there is no need for energy to be present. And let me just say, as the question is asked, I also have to say that if I'm taking a machine out of service, and I'm not going to do anything with it, I'm just going to park it and it's going to be idle and turned off, then it does not have to be locked out because there's no personal exposure. That's the key to lockout, is when people could be hurt because they're in contact with point of operation or a danger zone, lockout needs to be applied. If it's simply waiting, it could either be left unlocked, or if the company feels, the employer feels better about securing it, there are things called transfer lock systems, which can secure the machine in a holding pattern in an off position, preventing unauthorized startup or activation. But since nobody's planning on working on the machine, personal lockout locks do not have to be in place. And in fact, could be a problem, because if the person who applied the locks is not present when we're ready to fix the machine, then we have emergency removal considerations that can complicate things. So a transfer lock protocol is in the ANSI standard. It's pretty well called out. And I also want to leave one other thing out there for the audience. OSHA writes a really good guide to lockout. You can download it on the internet, and I find it to be awfully helpful. It's CPL 0200147. This is OSHA's instructions to their field inspection officers as to what is good practice and what is not. and transfer lock protocol is described as good practice in the OSHA CPL.
All right, thank you, everyone. Unfortunately, we have run out of time. I'm sorry we didn't get to everyone's questions, but all of today's unanswered questions will be forwarded to our speaker. Once again, I hope you take the time to fill out the evaluation survey on your screen to give us your feedback. That ends today's Safety and Health Magazine webcast. I'd like to thank Todd Grover, everyone at the Master Lock Company, and all of our listeners. Thank you, and have a safe day.